the thing that we're doing for this lesson. Thank you for checking in. Welcome. This is page 330. And on page 330, we're talking about what we can do knowing that all polygons have angle measures, the exterior angles that sum or add up, that is, add up to 360 degrees. In addition to this video, today's video is also brought to you by the word transversal. Remember, transversal is a line that crosses two parallel lines. Hey, I want to remind you that we have been looking at this GeoGebra website for a demonstration, and so link in the description. We're just to mess around with some ideas behind exterior angles of a polygon. So let's take a look at that right now, and I just want you to think about, in a triangle, there is one angle measure that's provided. That happens to be the exterior angle for a triangle, and then I'm going to jump to a quadrilateral, a square, and then to a pentagon. And I want you to see how those numbers change, because when we complete page 330, we're using those numbers. Let's take a look. Here it is. We have a triangle, and as the triangle collapses into the circle shape, and all three angles add up to 360, one angle is 120 degrees. Why? Why would it be true that this angle, or any of them on their own, are 120 degrees? Let's jump up to a square. As you collapse a square, and note the exterior angles on a square are 90 degrees, how is it possible that we can actually prove that? Prove that the exterior angles in a square are 90 degrees. Let's jump up to a pentagon. In a pentagon shape, the exterior angles, there are 5 of them. When the pentagon collapses into a circle, you get a sum of 360 degrees, but one angle in a pentagon is 72 degrees. Where are these 90, 72, 120 degree angle measures coming from? That's what we're going to make sure that we answer by the end of this video. Let's jump into the notes for today. When the sum of the measures of the exterior angles of a polygon is 360, how many sides does the polygon have? Honestly, there is no way to tell, because all polygons have 360 degrees for the sum of their exterior angles. So whether or not you have a triangle or a square or a pentagon, when you add up all of those exterior angles, they all add up to 360. So if you're telling someone else, hey, look, you should know what polygon I have because the exterior angle sum to 360, you are not telling the truth. You are not letting that person have enough information to solve it, because you told them a fact that is true for all polygons. Let's talk in the next one. Calculate the measure of each angle. You know, if we know that the exterior angles of all polygons add to 360, then you can take 360 degrees and divide by how many angles there are. In a triangle, there are 3 exterior angles. So 360 divided by 3, 120. That is where the 120 came from? Maybe? Okay. The exterior angles of a square. Again, it's a square, so its exterior angles add up to 360. But in order to figure out what one angle adds up to of the exterior angles of a square, divide by 4. How about for a regular pentagon? In a regular pentagon, there are 5 angles, 5 exterior angles. All 5 exterior angles add up to 360. So then if you divide by 5, you'll figure out what one angle on the exterior of the pentagon adds up to. And it's 72. Aren't these the numbers off the demo? This is how you find them. For the exterior angle of a regular hexagon, 360 divided by 6, 360 divided by 6, 36 divided by 6 is 6. There's a 0 on the end, so 60. In fact, this pushes us to a formula. If you want to figure out how many degrees one angle is for a certain sized polygon, you literally just take 360 and divide by the number of sides. That will be the measure of the exterior angle. Okay. Well, question 8 puts that formula to the test. Question 8 says we know that the measure of one or each exterior angle is 18 degrees. So how many sides does the polygon have? We're going to do a substitution. That's our second word of the day. Tell him what he's won. He's won a chance to solve this problem using substitution property. We're going to take 18 and substitute 18 for the measure of the exterior angle. Let's use this. Oh, I know. Okay. My solving utensils are ready. So we're going to substitute 18 degrees for the measure of the angle, which gives us 360 over n equals 18. You might be thinking from middle school or from whenever, sorry, bad shout out, I'm sorry, but that's usually when it happens, that someone taught you cross multiply. Don't do that here. If you multiply both sides by n, what was a fraction, 360 over n, no longer is. But you now have a new expression. You have 360 equals 18n. So to get the n by itself, divide by 18. All right, I need some help right here. I'm going to ask my calculating resource. Hey Siri, what's 360 divided by 18? No answer. But I know the answer is 20. So therefore, 20 equals n. We have a 20-sided polygon. There you have it. Those are the exterior angles of triangles, polygons, quadrilaterals, etc. We used substitution along the way. We used linear pair along the way. And so what I want to make sure, oh, there's my card, that you are able to do is actually solve for missing angles or missing some of the shapes. Thank you for watching this video. Thank you for watching Lesson 3 content. In the next video, we talk about Lesson 4, and we'll get to that content when that shows up. So once again, done a great job getting smarter, getting more mathematically knowledge every day. See you in the next video. Bye.